Hey guys, everyone okay? Cool. Thanks a lot for coming to our talk. It's been we've been building this for quite a while. Essentially, it's our journey through how we build security pipelines for our current place. We face some interesting tasks, and I believe we solve them in some interesting ways. So here's what we're going to talk about. Come in. Pretty much some questions for you, who we are, our environment challenge, some existing solutions we found and their limitations, our unique requirements that are unique to us, what we chose to go with. We'll give you a quick demo, advantages of what we did, and what we totally promise to do in the future, right? We'll try not to be yet another project that presents and then...
Wait, what are you committing us to now?
So, if you change the slides. Yeah, so I'm Spyros. I like to say I do security engineering. More often, I just chase people to fix things. I focus on application. That's why OWASP, right? That's my Twitter handle. I work for these guys. It's a London-based financial technology company called Thought Machine. They pay the bills. And I contribute to open source as much as I can. I've been doing OWASP things for many, many years now.
Yeah, and hi guys, I'm Henry. I also work with Spyros on the same team at Thought Machine. While he's breaking stuff, I'm trying to stop him normally. It's like a challenge. But I'm a backend engineer writing code and trying to write tools for security. And this is one of the things we've been working on that we'll talk about. You can also find me on various places like GitHub or Twitter as stake_.
So some questions for you first, so we can set the tone. Does anybody do any security testing in the release pipeline? Hands? Okay. Nice. We're doing good. We're doing good. Yeah. So you guys support multiple languages, right? Like you don't only start one like static code analysis tool and that's it, right? Three. Yeah. Good. Dynamic testing, anybody? Automatic dynamic testing, right? Because static just drowns you in false positives, right? And some things may be fixed upstream. Configuration per team? Yes, kind of, right? Yes, awesome, thank you. And who has less than 10 hours per week budget to do this? Right? Like when you tell your boss, thank you. We are in the same boat, right?
When you're spending time chasing people the whole time.
Yeah, like there is only 40 hours in your work week. Otherwise, you don't have a life. And you need to somehow prioritize things. And the company is a startup. We don't have budget for like a dedicated like pipeline security testing team as the others do. So I'm constrained. Hi, welcome. So you want to talk about our environment a bit?
So I'll introduce a bit about like our environment, which probably resonates with a few people, I'm sure. We run a microservices architecture on top of Kubernetes. And it's all very, lots of teams owning their own services, doing their own thing, doing their own languages. And with that, we also expect the developers, the engineers to own their own services. So they often deploy their own things. You don't like that much, do you? There's release teams involved, but they are normally just providing tooling to help the teams actually do their releases. And with that comes, with fintech comes a lot of traceability as well. Well, there should be, not always happens, but so we want to know like what scanners happened when, or what scans happened, what pen tests happened when, and how, and what were the results. And if clients come to us and say, hey, like we found this issue, did you see it previously? We can come back and say, oh, this is what we did.
Yeah, and also like if you ask our bosses, we do DevOps, right? That's the hot word here. essentially, it means we release as fast as possible so we can go to the customers as fast as possible, right? So we need to run behind people. They don't come to us, and we cannot block anything because that's not DevOps. And it makes sense in the current world. It makes sense. You cannot have like 6-month releases and then security having the ability to block things. That's not how we do things. And that's our challenge. So we onboarded a few months ago, and we found an environment with like Kubernetes, a bunch of microservices living and dying, teams working on projects that might be short-lived, but these projects needing the same amount of security as like the core product. We write in about 4 official languages, emphasis on official. And we needed to build something that's usable by engineers because quick release cycle, I cannot be the only one running things. So engineers needed to be able to find something. Ideally, it would run as a linter. And again, quick release cycle, right? So go to the next one. So the very first thing we did, as everybody, tried to be lazy and find something off the shelf
Efficient, not lazy.
Fair enough. And find something off the shelf or somebody else to borrow things from, right? Ideally, it would be a nice GitHub repository with all the things I need and then just import, run. Of course, it didn't work. So in the past and most presentations I've seen on the subject and talks with like some of you, everybody seems to be doing something like that. There are pretty good tools out there that are either commercial or non-commercial that do both static and dynamic analysis, e.g. Zap, for example. It's pretty good at doing dynamic analysis. And there are plugins for most CI environments that support said tools, and a fair amount of open source things. Bandit is one of my favorites. And however, all these are different tools. Everybody speaks their own language. The results all come in their own way. And then you do a lot of scripting to glue everything together.
Lots of hacky pen tester style scripting to hack things together.
Don't rub it in. And so scripting to glue everything together, or say things like, if this piece of code is Python, just run the Python pipeline. If this is Kubernetes, just run some container scanning and goes on, so that you are efficient and everything speaks to everything else and you understand what's going on.
Yeah, a thing that we're seeing with a lot of the existing tooling is that they often make a lot of assumptions as well. Like they assume you use GitHub, we don't. They assume you use CI Circle or Travis, we don't. And there's a few things like that which we're finding quite grainy in a lot of the existing stuff out there. So talking to our engineers and the decision makers in the company, we needed something that runs both locally and on cloud, because cloud-based company. It needs to run. Can you go to the next one? No worries. And then if you go, and then it needs to be environment agnostic, so it needs to run both on the MacBook of like some management person and the Linux machines of the engineers, also on the cloud, or pretty much in a lot of places. They didn't want custom builds for different runs, for different setups. It makes sense. And that was the important one. We proposed a solution that like runs on Jenkins and just dumps results to Elasticsearch. Got shut down very quickly. They told us that you need to be able to mix and match everything. So run locally, run exactly the scanners you want, output to your custom place just because you prefer something like Fabricator, or we might switch to Jira. So it needed to be able to do Jira, or I don't know, Elasticsearch. We'll have a person in our team whose favorite tool is Elasticsearch. So we needed to integrate Elasticsearch as well. And it couldn't be one monolithic thing. Most of the solutions we found are just like this giant monolith. You take it, forklift it into your data center or in a server somewhere, and good luck with changing it.
And most of all, it must play really well with the CI, because if you don't do it automatically as part of your build, why are you building it, right? So
yeah, we wrote Dracon. So Dracon, you can explain that. You're Greek. You can explain where the name comes from.
Fair enough. So Kubernetes has this affinity for Greek names. We don't know why. Somebody in Google must be Greek or must like Greek. And our manager definitely likes it. So he demanded the Greek sounding name. Dracon sounds like dragon, which is cool. Also, he used to be a very strict Athenian despot. So technically, this solution is meant to be kind of a strict baseline, like despotic, like scan for your code. Yeah, exactly. He said something like, I believe that the punishment for stealing is death, and there is no worse punishment for anything else. So let's kill him. Not great, but you get it. We definitely don't kill anybody.
Yeah, so as I mentioned, we're running Kubernetes. We run everything on Kubernetes. I think we have one internal service in the company that's not, and it's something that we just can't get rid of. But everything else is on Kubernetes within the whole company. We decided, so when we first started looking at writing this, about the same time Tekton came out. Tekton is originally written by the Knative Foundation, and is all about running CI pipelines on top of Kubernetes. Bare Kubernetes is a little bit hard to do that with. It's great at running services for long periods. It's great at running one-off jobs, but running jobs kicked off by something else is kind of hard without using something like Tekton. And then to basically step between all of our tasks that I'll describe in a moment, we decided that we'd make use of protobufs just to define a really hard API between all of our tasks. And this has been really beneficial from the point of view of we don't let pen testers do what they want and just output what they want. We basically define what we want from each tool and what we expect to go into the next place. It'll become a bit more obvious in a moment. We're using Postgres as a great data store. It's basically used as a staple in our company as well. It's a place where we store everything, and we're also writing everything in Go and Python. We started off with Python, but we're finding just dealing with Kubernetes a bit nicer in Go. The libraries are just a little bit better support, so we're slowly shifting that way. And we've one of the four languages that two of the four languages are Python and Go in our company that we officially support. So got great support in the company as well.
So you go for this.
Sure. So Dracon is a Tekton pipeline. And to explain a little bit about like what Tekton is, as a project or a library, if you like, that we use, an upstream resource that we use, it has a pipeline concept. And in each pipeline, there's a set of tasks, where one task will feed into another task. So, a really typical CI pipeline might have like a Docker build step Docker build step and a Docker push step. We're going to sidestep that because that's not what we're interested in security pipelines, but certainly what you could use Tekton for. And then each task has steps, and it might be like I don't know, like Docker build, and that will, I don't know, or what?
And Docker push, and then build Kubernetes config, and then deploy it or apply.
Yep, and then you can also pass arguments, and the arguments might be like which Git repository you're wanting to build from, or it might be like which parameters you want to pass to. In our case, which parameters you want to pass to Bandit as a producer in the pipeline.
Yeah, so this architecture is very critical for us because it allows us to template tasks, and in a task run, just provide a specific configuration to the team or the specific project. But I can have my PII or PCI task, which checks the code for really basic PCI stuff. And in the task run, depending on the team, you have a map with configuration so that you're not checking for Java for like Java vulnerabilities, if the team only writes in Golang, for example, that would be inefficient. So because of that, Tekton works really well, at least for security pipelines and for the way we do things.
Yeah, do you want to explain the API?
Sure. So the protobuffs are yet another project by Google. You can imagine it as an extension to the HTTP protocol. It's statically typed and statically formatted. So JSON on steroids, I guess. And for our use case, we have only 4 messages. Launch tool, what do you want to launch? Launch tool response, what came back from that? And a launch tool response has raw data that get digested to issues. And one issue might or might not have one or more vulnerabilities. So it's, yeah, just that. The next one. And here's how an issue looks like in protobuf format. You have several fields, 7 in this case. The first field that the protobuf is gonna read is a string with a target, pretty much what did you scan. The second is the type. This is a free form. It works for us because it can be either the tool name or the title or dynamic or static, or SAT tests if you run security-specific SAT tests or regression tests. And then human readable title, so you don't have to read the full description to find out which vulnerability is what. Severity as reported by the product. An optional CVSS, confidence as reported by the scanner, and the human readable description, so I can give it to developers without needing to fill in descriptions myself or like copy paste from OWASP cheat sheets.
And often the tools are providing descriptions as well.
Yeah. And so far we've covered what runs, how it runs, and how it talks to each other. However, we haven't covered the scripting from the previous slide. So we had to build a templating engine that will take arguments, pretty much what do you want to run, which order, what arguments. It does some templating magic and then outputs a pipeline. By the way, I believe this image is super representative of a security pipeline. You need 2 people to run it. It's a dangerous job, hence the hats. And in the background, something's on fire always. So, so it gives you a security pipeline, and it can either apply it for you as well, or it can just give you a template which you can store or apply for future reference.
Yeah, so to go over the architecture, I'm going to come back to this diagram a fair bit. So we'll go over it in a bit more detail. But first of all, I just want to cover these 2 guys first, the producers and consumers. We've started to talk about them a little bit, but let's define them a bit better. So producers and consumers, they're on the left side here. The producers, they're typically existing scanning tools. The ones that we use are GoSec, FindSec Bugs, and Bandit. And we're using OWASP dependency check yet? No.
Yes, we do.
Oh, yeah.
Yes, we do.
And these, so they're all these things. So the consumers, what they are a wrapper script around a tool. They launch the tool, then they parse the results and put the results back into our protobuf format. And it just means that the tool is isolated from the rest of the pipeline. And as long as you can write a wrapper script, which so far we've found them pretty easy to write, you just completely abstract the tool away from the results. On the other end, the consumers, these are things where you want to take data out of the pipeline into something else. The really useful one that we found straight away that we implemented first was Elasticsearch. Just being able to dump the data somewhere and run a Kibana dashboard, or be able to search the results manually. The other place is Slack. That's really useful as well. You end up finding we tried. Yeah, if you want to dump all your results to Slack, it gets a bit noisy, but we'll have a quick look at how we can minimize that with the enricher, which we'll come back to. But there's also like DFX Urjo you've started using.
Yeah, like you need eventually you start dumping things in Elasticsearch, but you cannot manage things. You cannot chase SLAs. You cannot do a lot of things with Elasticsearch. It's really good for dashboards and for knowing like vaguely what's your general vulnerability posture. Slack is great for metrics. Every time somebody runs it, you get an alert. It ran against like these directories found that many issues. These many issues were duplicates, or these many issues have already marked as false positives in the past because defect dojo. And you get some basic results day to day. And depending on how you feel that day, or if it's a vulnerability chasing day, you can invite people for a chat.
Yeah, and the other place is Fabricator, or which we use, but could be Jira just as easily. If you want to say open tickets based off scan results, you have to be careful about noise. It's the only problem.
Yeah, at the beginning we were just opening tickets. The people went tone deaf very quickly.
Signal to noise ratio is important, you know. Yeah. So back to the architecture. So as we've got here, we start off with a code setup container. Yeah, this basically gets your code into the pipeline. It takes some secrets. We pull them out of HashiCorp Vault, and dump, and basically clone our code and get it ready for the producers to do their thing. Then the producers they take their launch tool request protobuf, which says what they've got to do. They produce their results. And in a moment we'll go through a demo as well. Put together a video to show off Bandit. It was in the end,
yeah.
And then the enricher. This is quite an important step which we added in, not initially, but it became very obvious that we needed something here. This is just what we do is we take the results and we mark them to say if we've seen them before. So we mark them to say that they're a duplicate. Because then the rest of the pipeline can actually consume it sensibly. And the other, what else have we got?
And the other one is if something is a false positive, you don't want to be bothering people with false positives, because then you have angry devs at your desk, and that's not healthy. Not for you, not for the devs. So yeah, enricher goes into a database for everything that the producer stack produced, makes a hash, so it doesn't have to do a lot of calculations. Goes into a database, figures if the hash exists. If the hash exists before, marks it as duplicate. If the hash exists with a binary value that says false positive, it marks it as well as false positive, and then dumps it on a consumer stack.
Yeah, so the consumers, as mentioned before, like AppSecEU was a really early one. These are basically where you get your results and push them off to your end places that are consuming it.
So a consumer is essentially a tool that grabs enriched results, does something to them. That something is completely up to you, and dumps them somewhere. For example, our Elasticsearch consumer dumps raw results into Elasticsearch because different indexes do different things. Yeah.
Yeah, absolutely. So our feedback loop is we expect the consumers to, the producers to create false positives, but then the enricher is where the logic is to remove that data.
And if we see that we haven't seen a huge need to do this yet, but in the future, I've done it already for Bandit for a couple of things that were very specific to how we write code, and they were always marked as false positive. So in order to reduce like stress on database and all the things, I had to configure Bandit, but the rest of the results are quite off the shelf, I can say. But yeah, like the feedback loop is you're looking at it. Yeah, I mean, do you have an automated process? If so, we need to talk. Cool.
So point out as well was that like we don't expect. So back to what I said earlier about we're finding tools with a lot of assumptions about what you need and what you should have, like GitHub, which we don't. want you to be able to do what you want with the pipeline. If you don't have any Python in your code base, then don't run Bandit. That should be fine. If you don't use Jira, then don't consume Jira. And exactly you might just want to see a whole lot of raw results in Elasticsearch and deal with it after that. That's absolutely fine. You can mix and match how you like.
And that's the important part for us. Go next. So we started building producers and consumers for pretty much everything we had, and then everything under the sun. And eventually this created a catalog of tasks, which became a part in the repo called tasks, and our central registry, which is called registry. So producers, I said, wrap tools that dump protobuf things, and then consumers, wrap tools ingesting protobuf messages from producers. And because we have a place in the registry where people can go look at the list of producers we support, the list of consumers we support, they can mix and match easily. And yeah, so after we built this, we had a major discussion with several high-level people in the company, saying, trying to figure out where does this thing fit in. So the answers were pretty much something like that. You could run it after your CI build if you want. It fits anywhere. It can be used as a linter, or it can be used as an early warning system. It can be used even to
on your release cycle if you want, although that would be very late.
Yeah. More draconian. Yes, exactly. And somebody asked the question, what if we prevent releases? I think we both facepalmed at this point, right?
Yeah, we're very much, the whole security team company is very much we want low friction. We don't want to get to the end of the release cycle and be like, oh no, you can't do that. We need to have it right at the start, and the earlier the better.
Exactly.
Yeah, it's not our job to make that risk decision. You're right. Yeah. Take that risk on. Absolutely.
Also, our job is to give a warning as early as possible, so it is as cheap as possible to fix it, right? If a development team has been working on it for 6 months, and then at month 6 plus 4 weeks, you tell them, hey, no, this is not going in the release. They're going to grab pitchforks.
Yeah, so, do you want to talk about where we actually ended up putting
Sure.
it?
So we ended up creating a second pipeline and putting Dracon in it. It's the security pipeline, for lack of a better name. So somebody pushes to a branch, regular pipeline does its thing, and then Dracon does its other thing. And then afterwards, it generates some reports, which internally we call them attestations, because parts of these reports also reach clients, depending on contracts. And then next one, the reports come to us for manual review, because again, false positives, or maybe duplicates, or maybe any automation in security needs humanized for triage. If you show me a thing that does it automatically, I will be very skeptical.
Should we do a demo?
Yeah.
Yeah. Oh, no. I see that for you.
Right. This is where everything breaks, right?
Okay. So we report that.
Aha. What? You never had a video break? So if you put it on full screen and you pause again, second. No, actually, I'll go back there. It's much better. Yeah, I'm in your neck, right? So, thank you. So, Dracon demo is our pipeline environment. It's just a namespace on Kubernetes, right? Makes sense. And because I'm lazy, I launched it with a script. Pretty much the script sets a UUID. The UUID is the scan name. I prefer it to be UUIDs. We started with human readable scan names, I was imagining something like scan launched by dev blah or by job whatever. People started mashing the keyboard, and a UUID is much more readable than QWERTY 1 to 3. And then it replaces this UUID in Kubernetes template, which this specific template will run DefectDojo, and it executes it. So a pipeline was created, specifically a task run, and now we will get it. It has 5 steps, and it's still running. So if I go to the logs, and if I open the logs for the code step, it downloaded a bunch of things, installed a bunch of other things, and cloned. I think for this, we're using a tool called JunkGoat.
Yeah, we decided rather than exposing our internal code base, we'd find something online. So we came across JunkGoat, which is just a vulnerable Django project.
Yeah, sorry guys, you don't see internal stuff today. Yeah, and it has known vulnerabilities that exist in write-up, so we can check if the configuration and the tools are sane. So if you click, oh yeah, there we go. So that's the logs from the enrichment service. It found a bunch of duplicate issues. I had run this before, so we could see the enrichment service at work. These are the hashes of the duplicate issues. And if anybody asks, yes, they are MD5 hashes. No, I don't expect collisions, because I don't expect to have that many bugs. I mean, I try to not have a lot of security issues, right?
Just said it in a talk, it's going to happen. You just jinxed yourself.
Okay, official promise. If it happens, I'll buy you a beer. So the second one is step producer mark producer phase 0, because my naming conventions are awesome. It ran Bandit. Bandit ran with 142. I think it's the plugin number, and then from 0 to 50% to 100%. From a producer, you don't need a lot of output. You just pretty much need to know if it ran or if you have a bug. And then if you continue, consumer phase 1 run, found a bunch of issues that are duplicates with a count of 2, pretty much. Duplicate issues do not start with a count of 0. That would be counterintuitive, right? And you can attack me now. And the second one, for good practice, I always try to add to the pipelines metadata step. Pretty much the last step finds how many issues were found, how many of them were a duplicate, how many of them were enriched. So if the exact same pipeline runs like 4 different times with 4 different numbers of issues found, results enriched and results duplicate, I know I need to go back to the drawing board or figure out a way to fix it.
I think you do wrong unless they use the saying of location of the issues found.
Yes, we'll go to that in a second. So this is DefectDojo. If you're not using DefectDojo, it's a pretty good vulnerability management tool. Most of all, it's free. And it's from OWASP. Yes, 100%. Yeah. So DefectDojo allows you to do a bunch of things. This is a product I've set name Core 3, and it has 2 engagements. One engagement, hello AppSec, and another engagement called continuous scanning. This created a test called static check, because it runs static code analysis. And these are the issues it found, quite a lot of them, pretty much a bunch of import by crypto and whatever in different places. This is how one step looks like. Can you go back for stop? Yeah, thank you. So the description has all the Dracon metadata, pretty much what the scan ID was, what tool name I used, Bandit, what the type of the issue was. It imports by crypto, which has known vulnerabilities. The confidence for Bandit, confidence 3 means high. And yeah, I mean, if you import by crypto, you cannot mean something else. And the description, pretty much. So now I'll go back and launch another pipeline that
So what's this pipeline doing?
this pipeline brings all the results, raw and enriched, into Elasticsearch for metrics. I could have done both in one pipeline, but then the demo would be very short, and we would underrun the time, and that's not good in a talk, right? Yeah, thank you.
No, seriously, it's just to make it a bit more obvious as to what's going on.
So, kubectl, Dragon demo, get the pods. Second one, if you see the first one is completed, so it doesn't take a lot of resources. You don't have things running constantly. We tried with certain pods that would always run, and then we plugged Kubernetes. So you get the logs from the second one.
Type faster, man. Type faster.
Sorry, man. So bunch of duplicates again, exactly the same number of duplicates because it found the same number of duplicates. Yeah, right? We know we don't have a bug. So you go back to Kibana, and this is the Dragon index. If you go to discover, you will see that this specific one, because we only filter specific things, has 2 issues with severity 3, confidence 3, so high severity, high confidence, and they're both PyCrypto. Oh no, one PyCrypto, one hard-coded SQL, and I've opened the PyCrypto, and can you pause? 1 second? Thank you. So this is exactly what an issue is, as I said before, right? Confidence, optional CVSS, Bandit doesn't do CVSS, so 0. A description, is it false positive? False, mainly because I haven't gone into Defect Dojo to mark it as false positive. When it was first found, scan ID, scan start time is configurable. You will see that is before the first found, right? So it was first found today, but I set the scan start time in the YAML to be in the past to show that the scan start time can be anytime you want. So you can play around with however you find things. Severity. Sorry, it's gone. No worries. You need to scroll to the video all the way. Somebody said that the demo would work, right? Imagine if we had the live demo. Yeah. So, yeah, a bit more, tiny bit more. Yeah, a bit more. There. Cool. And the target is app management commands seedpy. I haven't found a way to decouple it from the paths of Tekton /workspace scan source is Tekton. And yeah, I need to figure this out, but we will. And then the title, tool name, type, pretty much sorted. And if you... I could, or maybe in the consumers, on the base, like the base consumer class. But yeah, I mean, yeah, could. So yeah, we made this. It runs as you saw. Advantages, you can mix and match any task you want. So yeah, I want Bandit to Defect Dojo, find sec bugs to like something else. And then I have some legacy IBM, IAX, like whatever, and they need to go into like some specific place because they are my PCI zone or whatever. So this goes there.
Yeah, wrapping tools, as I said, we found it quite easy. It seems pretty straightforward, as long as the tool behaves well, which so far so good. Touch wood.
Any what? No. Startup?
Yeah. Runs anyway. So basically, like that demo was recorded in Minikube on a desktop. We're at the moment running it both in a Google Cloud cluster, but also in Minikube.
Yeah. So it is CI friendly. I mean, most CIs do Kubernetes these days, and if your CI doesn't do Kubernetes, I mean, ask them to do it. I guess. So what's the future for us?
Support IS tools.
We need to add way more images. We have several things that we haven't integrated yet. The Jira integration is taking a while, mainly because Jira. We have Zap running, but as the baseline, not very smart scan, which doesn't give us a lot of flexibility. We need to do a full end-to-end tests, proxy through Zap. Zap finds everything and then goes on to scan everything really cool.
You basically need your service running outside of it. It's tough.
Yeah, and Tekton doesn't do services yet. So we cannot integrate it with Tekton. So we need to fix a templating engine in order to do all this, but it takes time. And this is important to us. We haven't yet found a reason to extend our messages, but a good example is Zap. It provides automatic remediation, like remediation steps come with the finding. And it would be cool to have an extra remediation step. That said, we do not want to add like arbitrary key value like maps in protobufs, because then protobuf becomes JSON and kind of defeats the point, right?
If you're CWE,
Yeah, you can. That's the things you can do, but like not everybody also reports CWEs. It's a sensitive situation to find like the common part.
Yeah, I quickly mentioned that like we didn't build all the stuff like Tekton or Kubernetes ourselves, so I guess like a more of a thanks to the people who have provided all the tools that we use. There's a lot out there, including the OWASP tools, like, and being able to come here and talk about it is really useful. Yeah.
Thank you, OWASP. Thank you.
Talking about open sourcing it. So we were hoping to get it open source for this conference. It didn't quite happen, unfortunately.
and make it an OWASP project. Yes.
Ooh.
Good idea. Yeah.
Yeah, so watch this space. We do have a repository for it already. It's actually blank.
This talk will be uploaded there along with the video and some readmes today.
Yeah.
It will be full in like 1 hour.
Wait. What are you committing us to again? Yeah, so this is where it's going to live. Also, we'll announce it as things come up on our personal Twitter accounts. So feel free to follow us.
So the idea is we'll upload the talk and maybe readme, and then as we open source things. The main problem, we have an internal build system based off Google's Bazel. It's also open source. It's called Please. And it does everything for us, but
it's tightly coupled to that build system, unfortunately. So.
Yeah, like an open source tool that you needs like 3 other open source tools to run. It's not really usable, so it takes time to decouple from things.
Yeah, but it's going well so far, and we'll keep you posted. Do we have time for questions? No time?
If you want to ask questions.
Yeah.
So questions?
We won't.
Yeah.